Hello, today we will discuss power of an AC circuit. All of you know the power is the rate of doing work. And in DC circuits, the power is represented by the product of voltage applied to the appliance and multiplied by the current passing through it. But in an AC circuit, in which we will use the appliance resistance, the capacitance, and the inductance, by using resistor, capacitor, and inductor, the current on the AC circuit is the instantaneous current, which is the function of time, and the voltage is in AC circuit is also a function of time. So the current and voltage both are regularly changing with time, and we use this voltage, which is the function of time, is the instantaneous voltage, and it is represented as V is equal to V naught sine omega t. And the current I is equal to I naught sine omega t. It may have some phase difference due to the appliance conditions. Let it is phi. Here, the voltage and here the current having a phase difference of phi. It may be positive, it may be negative. So the power across the AC circuit on the appliances is the instantaneous power. And the instantaneous power is V instantaneous into current instantaneous. So we may put the value of instantaneous voltage V naught sine omega t into I naught sine omega t minus phi. Here we have sine omega t minus phi. It is in form of sine A minus B in trigonometrical equation. We know sine A minus B is equal to sine A cos B minus cos A sine B. So we may open this one, angle values. So instantaneous power on is AC circuit is V naught, I naught, sine omega t into sine omega t cos phi minus cos omega t sin phi, right? Now we may open this equation. P instantaneous is equal to V naught I naught sine omega t into sine omega t, that is sine square omega t, cos phi minus sine omega t cos omega t sin phi. Now we will use another trigonometrical equation. Sine square theta is equal to 1 minus cos 2 theta by 2, and 2 sine A sine cos B cos A, 2 sine A cos A is equal to sine 2A. So P instantaneous is equal to V naught I naught into sine square omega t may be written as 1 minus cos 2 omega t by 2. 1 minus cos 2 omega t by 2 into cos phi minus sin A cos A is equal to sin 2A divided by 2. So sin omega t cos omega t will be sin 2 omega t divided by 2 into sin phi. Then we can write here P instantaneous is equal to V naught I naught by 2 into cos phi minus cos 2 omega t cos phi minus sin 2 omega t sin phi. To find out the average power across the AC circuit, we will integrate the instantaneous power with respect to time. So P average, that is average power, is equal to integration of instantaneous power for full cycle, that is for 0 to its time period t, divided by the total time, that is time period t. Now we plug the value of P instantaneous, then it is equal to 1 by T V naught I naught by 2 integration of cos phi 0 to t dt minus integration of cos 2 omega t cos phi dt 0 to t minus integration of sine 2 omega t sine phi dt 0 to t. Now we have to solve this equation to get the average power. We will get here V naught I naught by 2t into cos phi integration of 0 to t dt. Here we take cos phi out from the integration as it is not depending on time minus cos phi integration of cos 2 omega t 0 to t minus sin phi integration of sin 2 omega t dt. Here the time angle of cosine for full cycle will be 0 and time angle of sine for full cycle will also be 0. Hence, P average will be equal to V naught I naught by 2t into cos phi and integration of time for full cycle is t. Then we may cancel t and this t. Then what we will get? P average is equal to V naught I naught by 2 cos phi. So we can write here P average as equal to V naught by root 2 I naught by root 2 cos phi. V naught by root 2 is Vrms, that is effective voltage or the real or the virtual voltage, and I naught by root 2 is Irms or I effective. So P average will be equal to Vrms into Irms into cos phi. This equation tells about how to calculate the average power on an AC circuit. Here Vrms, Irms is the effective power and cos phi is known as power factor. We will discuss The power factor